Hey, welcome back. Today we're looking at 2.4 rates of change and tangent lines. So this idea of tangent line is the idea we've kind of built up to get to this whole limits continuity talk that we had through Unit 2. So we started off with the average rate of change, right? We said that this is a change in y over change in x, which is equal to the slope. So let's go ahead and just find the average rate of change, which should be pretty easy. It's kind of like an Algebra 1 / Algebra 2 type concept. So we're looking at the change in y over change in x. Okay, so let's do it at the end. So let's do f of 3 minus f of 1 over 3 minus 1. Right, that would represent the changing in the y because the function tells us our value. So f of 3 minus f of 1 on the top. And then the change in x, because we're going from 1 to 3, is 3 minus 1. Okay, so if we plug this stuff in, then we get f of 3 is 27 minus 3, which is 24, minus 1 minus 1 is 0, over 3 minus 1 is 2. So the average rate of change over the interval would be 12. Okay, so let's talk about tangent line now. So tangent line is the slope at a point. So we kind of illustrated this the last time when we were talking about using our numbers, our function, and trying to make the 2 points overlap. So the tangent line would be just, given one point, we could find the slope exactly where it would be on that line. On that line? Maybe not on that line, just from the line, I should say. Okay, so this tells us our instantaneous rate of change. We used our algebra to find the instantaneous rate of change earlier with the limit as h approached 0 of f of x plus h minus f of x over h, right? We did the whole algebra thing to find the tangent line's slope. Okay? Excuse me. So it says find the slope of y equals x squared at 2, 4. Write an equation for the tangent line. So, right, we said we're going to take this other point here, and the difference between this is going to be h. And we want to make it so that this point gets ever and ever closer until we're overlapping. So the h represents the distance between our actual point, 2, 4, and this imaginary point that we have that we're trying to get ever and ever closer to be 0, right? So if the distance between the points is 0, therefore they're overlapping, right? So that's the whole reason why we're trying to take the limit as h approaches 0. Okay, so let's do that. Let's do limit as, h approaches 0. Let's write the whole thing out of f of x plus h minus f of x over h. Right, so this is just another version of change in y over change in x, which is the slope, or rise over run. Okay? So yeah, we can't plug in 0 yet, right? Because we have the h in the bottom. But what we want to do is we want to get it to a point where we can substitute 0. There we go. We want to try to get this to a point where we can substitute 0 in for h algebraically. Okay, so what we know is that our x is going to be 2, right? So all these x's here are going to be 2. Let's plug that in. Limit as h approaches 0 of let's just put it all in x. Our function is 2 plus h, right? We substituted our 2 in for x. And the function is x squared. So we're going to plug that into x squared minus 2 squared over h. Okay, like we did a couple lessons ago, we're going to have to multiply this out. 2 plus h squared means 2 plus h times 2 plus h. Hopefully some of you guys are good at doing the distributive property slash FOIL method that we can do it in our head. So it's going to be 4 plus 4h plus h squared, and then we have this minus 2 squared is 4 over h. So this is kind of playing out like we did the last time we did our instantaneous rate of change. 4 and negative 4 cancel. What we're left with is a bunch of h's, which is exactly what we want, because then I'm just going to write this as two separate fractions already. 4h over h, the h's cancel. H squared over h, one of the h's cancels in the top and the one in the bottom. So we have the limit as h approaches 0 of 4 plus h. Now, because we don't have h's in the denominator, we can make h 0. So this whole thing is going to be 4. So at this point, the slope is 4. Now it says write an equation for the tangent line. Crappy part about this is that it's not crappy. It's just that we need to remember what's the best way. We're given a point and we know the slope. So let's use point slope form. So the thing to remember about on your test, if you're doing the paper, if you're doing the free response portion, if it asks you for an equation for a line, as long as you've written an equation of line, you don't have to simplify it. So the crappy thing about the test is if you write an equation, let's say point slope form, and you're feeling ambitious for whatever reason, you're like, hey, let's write this in slope intercept form. If you screw up any part of the process of converting it, you get no credit. So once you've already answered, once it's asking you for an equation and you've given them an equation, stop. Don't try to do anything more to it. Now, the other side of that is that if you're doing the multiple choice part of your exam, you might have to convert it from point slope to slope intercept to see which one is the correct answer. So it is a skill, but unless it specifically asks you to do it, do not do it. Once it asks you, if it's asking you for an equation and you've given them an equation, stop. Right, so let's get back to this. So in point slope, we're just plugging in. Our point was 2, 4. Our x is 2, our y is 4. So y minus 4 equals our slope, which we found was 4. And then x minus our x from our point is 2. And we're done. This is the equation of the line tangent to this graph at 2, 4. Okay, so it's a lot. They do ask you to do this on your test, so make sure that you understand how to do it. But again, on your test, once we figure out the easier way to find the slope at a point, it's going to be a lot simpler. Just remember, if it's asking you for an equation, the easiest way probably would be to do point slope. Okay, next one. Let's find the slope of a curve at a point. And this time we're using A's and H's, but really we know that these A's can be X's. It's fine. All right, so it's telling us find the slope at x equals a for f of x equals 1 over x. So we can use this one, we can use the other one. It's fine, either way. So we're starting off with f of a plus h minus f of a over h. And we can't plug in h or again because h in the denominator is going to be 0 and then it's going to break our math rules. All right, so what we're trying to do is symbolically find what this would be. So, okay, so we've got 1 over a plus h minus 1 over a all over h. I don't think I left myself enough room here. All right, hold that thought. We're going to move to another sheet at the very end. All right, so limit as h approaches 0, 1 over a plus h minus 1 over a over h. All right, so because we have a rational function, we have our variables in the denominator. It's going to be tricky, but the key idea here is we want to do common denominators because we're subtracting in the numerator, right? So we're going to, in order for us to have common denominators here, I'm going to multiply by a plus h, and then here I'm going to multiply by a and a. So, right, we didn't change the value of a function because we're multiplying by the same number on top and bottom, which is technically like multiplying by 1, which does not change the value. It just changes the form. So now let's rewrite this whole top part. So now our common denominator is a times a plus h, right? Each of these have the same denominator. This first part is going to be a times 1, which is a. And the second part is going to be minus 1 times a plus h. So that's just going to be a plus h. And then this whole thing over h. Okay. A minus a is 0. Minus h is negative h. So we have negative h over a times a plus h divided by h. Now what we know here is that anytime we have a division, right, we have a complex fraction. Those of you who had my class, we said that anytime we have a complex fraction, we take the division symbol, this division symbol here, right? And we're going to change that to a multiply by the reciprocal. So we have negative h over a plus h times the reciprocal of h, which is 1 over h. Now the cool thing here, right, for those of us who are math nerds, is all this stuff is going to start to simplify now. So h and h cancel out. So on the top we have negative 1 over, now because we have the a plus h in the denominator but it's in parentheses, we can substitute 0 in from our limit. So 0 for h is going to be a times, well, a plus 0 is a again. So this whole thing is 1 over a squared. So what we did was we symbolically and algebraically represented this function's point, or that we can find the slope. We can use this to find the slope at any point of our function, not just one particular point. So this is what's called the derivative of the function. And again, this is really tedious and a lot of work, but it's good for you because it helps you practice algebra and different ways of solving algebraic problems. But yeah, eventually it's going to get way easier, so don't freak out too much. All right, so let's get back to this part. We found that this whole thing is going to be negative 1 over a squared. So in order for us to find the slope, where does the slope equal that? Well, okay, well, this represents the slope. We're figuring out when it's equal to negative 1/4. All right, because we have a proportion here, we can cross multiply. So a times negative 1 is negative a squared. And then negative 1 times 4 is negative 4. We can divide by 1 to get rid of those negatives. And then when we divide, a is going to be at positive and negative 2. So what we would see is if we took this function, right, and we wanted to find where the slope is equal to negative 1/4, we just plug it in. We say that this is our slope function. That represents our slope at any point. When is it equal to that? It's equal to that when a is equal to positive or negative 2. Okay, next thing is normal line. A lot of people get mixed up here, normal line and tangent line. But the normal line is just the perpendicular to the tangent. Now, the cool thing about perpendicular and normal lines, and this ties all the way back to Algebra 1, is that these two perpendicular slopes are opposite reciprocals. So let's say that our tangent line slope was 1/4. Well, we know that the normal line slope would be the opposite reciprocal. So because this is a positive, the normal line would be negative, and then we take the reciprocal, 4/1. So that's how easy it is. So if you can find the tangent line, you can definitely find the normal line pretty easy. All right, so it's asking us, write the equation for the line normal to the curve f of x equals 4 minus x squared at x equals 1. Okay, let's go ahead and do it. So we're going to set this up again. 4 minus x is 1. So one minus 1 plus h squared, right? So we're saying that we're using the form x plus h, f of x plus h minus f of x over h. Okay, so subtract 4 minus, let's put big parentheses here, 4 minus 1 squared. All right, we put the big parentheses to make sure that we remember that minus sign applies to the whole right side. And put that over h. Okay, let's expand it, I guess. We're trying to find the limit as h goes to 0. Okay. Okay. 4 minus, let's expand this. 1 plus 2h plus h squared minus 4 minus 1 squared is 3 over h. Okay, so 4 minus 1, right? The minus applies to this whole parenthesis, so be very careful. 4 minus 1 is 3. 3 minus 3 is 0, so this, and this cancel out. The negative sign applies to everything in here, so negative 2h minus h squared, right? Because we distribute that negative sign over h. Okay. Now we're allowed to cancel h's, right? So 2h divided by h is 2. H squared divided by h is h. Now we can plug in the limit as h approaches 0 into our h. That's going to be 2 minus 0, or negative 2 minus 0, which is, let's clean this up, negative 2. So our slope is negative 2. Now, this is the tangent line slope, right? Tangent. So the reciprocal, the opposite reciprocal would be the normal. So the opposite sign would be positive, reciprocal 1/2. So this is the slope we're looking for. And we're using this point. Oh, well, I guess we don't have the y, so let's change this color here. If we're to plug in x into our function, so 4 minus 1 squared is 3, so y equals 3, x equals 1. Now we have enough to fill in our point slope form. So let's do so. So our point slope form, y minus y1 equals m x minus x1. So we have y minus 3 from our point. Our normal line slope is 1/2. And then our x is 1. And we're done. Okay, so kind of similar to finding the tangent line slope or equation of a tangent line, but we're just applying the normal line idea to it, where we take the opposite reciprocal slope and plug it in. All right. I believe this is the last one. So it's saying find the limit f of t plus h minus f of t over h if f of t is equal to 2t squared minus 1 at t equals 2. So because I guess we went through a week of this, I'm just going to give you a little preview of how easy it actually is to do the derivative here. So I'm going to tell you, just by looking at this, I know that the derivative, or the derivative function here, would be 4t. Now I'll explain how we do that later, but I'm going to just kind of like go through the math on this. All right, so I'm going to do limit as h approaches 0 of 2 parentheses, our t is 2, so 2 plus h squared minus 1 minus another big parentheses here, 2 times 2 squared minus 1 over h. Okay, and let's go ahead and expand that. So that's going to be 2 parentheses 4 plus 4h plus h squared minus 1 minus 2 times 2 squared is 4 times 2 is 8 minus 1 is 7. Okay, so we have excuse me, over h. We might as well distribute this thing. So we have 8 plus 8 plus 2h squared minus 1 minus 7. 8 minus 1 is 7, minus 7 is 0. So all these constants are gone. Right, and then we get to this part where we only have h's left, which is nice because we know they're going to cancel. So 8h divided by 8h is 8. 2h squared divided by h is 2h. Now we're allowed to plug in the limit because we canceled the h in the bottom. So we plug in our 0 here. 2 times 0 is 0. This whole thing is going to be 8. Now, let's think about it here. So if I did my derivative here, that's my derivative function, right? So at time 2, if I plug in 2, oh yeah, I get the same answer. And I did it in like way less time. Now, I'm going to just give you a preview for it. If you guys feel comfortable using it, use it. But also remember that you do need to be able to do this long version. Excuse me. And this only works for polynomial functions right now. We're going to get into different ones later, but for now, we're going to be talking about polynomial functions. So the thing here to remember is the derivative of, let's say, x to the n, right? So any number, excuse me, is going to be n times x to the n minus 1. And you might be saying, okay, wait, I don't know, that doesn't make sense. And if it doesn't make sense at this point, fine. But all we do really is we take our, so we're started with this, right? So we take our exponent, drop it down in front. So in this case, it would be 2 times 2t. And then subtract 1 from the exponent to the first, right? It started off with 2. We subtract 1 from our exponent's 1. So 2 times 2t to the first is 4t. Any constants that we have, like, so we have minus 1. Well, the exponent there, well, actually, we don't have an exponent there. We don't even have a variable. So any constant terms, they derive out. That's going to be 0. Okay, not to be confused with the constants in front with the multiplication of the term. So each term we have to treat as a separate derivative, but for this case, yeah, it's pretty straightforward. You take the exponent, drop it down in front to multiply, and then you subtract 1 from the exponent. So let's say we did something like 3x squared. Let's do something bigger than that. Let's do 4x cubed plus 2. Okay, so we have 2 terms here, right? So we apply this idea, we drop down to 3 times 4, that's 12x, and then 1 minus, or 3 minus 1. That would be your derivative function, because this part, if we derive any constant, it becomes 0. So yeah, just a little bit of preview for that. Okay, that's it for today. Good job. If it works for you, you guys can use the shortcut method for now. But do also remember that you need to be able to do it the long way, the ugly way. It's good for you. Okay, good job.